Conditional statements. Objective: 1. To recognize conditional statements and their parts. 2. To write converse, inverse, and contrapositive of conditionals. The study of conditional statements and their truth values is the foundation of reasoning. Conditional statements. A conditional is an if-then statement. The hypothesis is the part P following the if. The conclusion is the part Q following the then. So we're saying if the hypothesis, then the conclusion. The symbols that we'll use, and you'll see most often, is P arrow Q, and it's read if P, then Q. Or sometimes P implies Q. Most often you'll use the if-then model. And the diagram, which is rarely used on any test or even in the textbook, but this is what the diagram indicates, that P is the conclusion, or what we want to get, and Q is what we want to get. P is inside our conclusion. Example 1. What are the hypothesis and conclusion of the conditional? If an angle measures 130, then the angle is obtuse. Now we know that after the if, it's if the hypothesis, then the conclusion. So we're saying if the hypothesis, an angle measures 130, then the conclusion, then the angle is obtuse. Today's going to seem a lot like an English lesson to you. Hypothesis, an angle measures 130. Conclusion, the angle is obtuse. Now guys, notice that doesn't include the if or the then statement. It's just the hypothesis, an angle measures 130. Math Excel will count it wrong. I will count it wrong if you include the if or the then part. Example 2. How can you write dolphins are mammals as a conditional? Meaning, how can you write dolphins are mammals in if-then form? Okay, so we could say if an animal is a dolphin, then it is a mammal. Now, we have to add some words to make the sentence make sense. So if an animal is a dolphin, then it is a mammal. Now, you might have written it something a little bit different. You might have said, if it is a dolphin, then it is a mammal. But what is it? We're talking about an animal. So be a little bit more concise so your English teachers don't just die when they see the sentences that you write. The truth value of a conditional statement is either true or false. Conditional statements. If it is your birthday, then you'll have cake. So we're going to look at this because these are the different cases that could happen. You could have, the hypothesis is, it is your birthday, conclusion, you'll have cake. So in the first case, the hypothesis could be true and the conclusion would be true, which would make the conditional value also true. Case 2, the hypothesis is true, it's your birthday, but you don't get any cake. And so we didn't get what we wanted or expected, so this is going to be false. Now this is the one that gives people the most fits. It's saying that it's not your birthday, but you got to eat cake. So is the conditional value true or false? It's true. Because we're looking at the conclusion, and if the conclusion is true, the conditional statement is true. In case 4, it says it's not your, basically it's saying it's not your birthday, you didn't get to eat cake. So did you get what you expected? Since it's not your birthday, you didn't get to eat cake, it makes it a true statement. Truth values. If you get what you expected, meaning if the hypothesis is true and the conclusion is true, you got what you expected. If the hypothesis was false and the conclusion was false, that's something you expect. One way to think about this is think of your parents use if-then statements all the time. They may say, if you get good grades, then I'll help pay your car insurance. Well, you got good grades, they paid your car insurance. That's a true statement. If you didn't get good grades and they don't pay your car insurance, you expected that to happen, so that's also true. But the other thing that makes this true is if you get what you wanted. And the conclusion is always something you want, even if you're suddenly going, well, I didn't want that. Well, that's how you have to look at the conclusion statement, that it's something that you wanted. Because what if they said, if the statement was still, if you get good grades, we'll pay for your car insurance? Well, what if you get bad grades and they still pay for your car insurance? You got what you wanted, and so the conditional statement is still true. The only time it's false is if the hypothesis is true, but the conclusion was false. So that would be like saying you got good grades, but then your parents didn't pay for your car insurance. Example 3. It says if a conditional, it should say, is the conditional statement true or false? If it's false, find a counterexample. If a month has 28 days, then it's February. Now I can see where some of you might say this is true, because February is the only month that could have 28 days. But do all months have at least 28 days? Yes. And so this is false. All months. Months have at least 28 days. Okay, B says if two angles form a linear pair, then they are supplementary. Well, by definition of a linear pair, they form a straight line, which means they equal 180. If they equal 180, then they're supplementary. So, statement B is true. A negation of a statement P is the opposite of the statement. The symbol, looks like a squiggly P, is read not P. Conditional statements. Conditional statements, we have the traditional conditional statement that we already learned about that says if P, then Q. Then we also have the converse of that statement that says if Q, then P. We switch the conclusion and the hypothesis. We also have the inverse, which negates both the hypothesis and the conclusion, which in symbols is if not P, then not Q. And then the contrapositive, which says if not Q, then not P. Now guys, on these, you're going to want to write them down at the top of your paper and have them handy. As long as you know what the symbols look like, I would use the symbols and just say something like inverse, here's a symbol, not P, then not Q. Because it's kind of hard to keep these straight in your mind all the time. And this would be one of the few times that I'd let you have a 3x5 card for the test, just to keep those things together. Now when you have a 3x5 card for the test, it's only formulas and definitions, no examples. Equivalent statements. Equivalent statements have the same truth value. The conditional and its contrapositive are equivalent statements. The inverse and the converse statements are also equivalent statements. Example 4. It says, what are the converse, inverse, and contrapositive of the conditional statement? Determine the truth value. It says if 4x plus 8 equals 28, then x equals 5. Now notice the converse is when we flip. The converse was if q, then p. So we just flip-flop them. So we're saying, because this is I need to use something besides red. Here's p, here's q. Notice how in the converse it flips it. It says if x is equal to 5, then 4x plus 8 equals 28. The inverse was if not p, then not q. So it says if 4x plus 8 does not equal 28, then x does not equal 5. And the contrapositive flip-flops and says if not q, then not p. And it says if x does not equal 5, then 4x plus 8 does not equal 28. Feels a lot like an English class today, doesn't it? Okay, lesson check. Make sure you try these before you come to class, and then we'll go over them together to make sure you're ready to start your Math Excel.